In this video, we'll solve this question. It's going to be our first system of differential equation. I have a system in y1, y2, y3. I want to start by writing it in matrix form just so we can practice it and see where the linear algebra comes from. Then I'm going to find the differential equation, the solution to the differential equation. The general one means all solutions written with constants. And in C, I'm going to find a particular solution. So I'm going to find one choice of y1, y2, y3 that has this initial condition true. All right, so let's start. Y is going to be y1, y2, y3. So y prime is y1 prime, y2 prime, y3 prime. And if I write this system out, I have that y1 prime, y2 prime, y3 prime is equal to 5y1, 3y2, and minus 6y3. I want to write it like this. So we've been practicing this. I want y1 to be multiplied by 5, and then I don't want any y2s or y3s. In the second row, I want y2 to be multiplied by 3. I don't want any y3. And in the third row, I don't want y1, I don't want y2, and I want minus 6 y3. So here's the matrix that I need to write this system as an equation like this. Notice that in this case, well, what's special about this matrix? Exactly, that matrix is diagonal. In a case of a diagonal matrix, it will not be hard to solve it. And so you see where I'm going. If a diagonal matrix is easy, we're going to start with any matrix, and to solve the system, we're going to diagonalize it. But let's do this one. So we're happy that A is diagonal because that's going to make solving this system easier. Alright, so I want the general solution. Again, that means I want all solutions written as an expression with constants. If you notice, my first row tells me that y1 prime equals 5y1. Well, that equation doesn't involve y2 or y3, so we know how to solve it. The proposition gives us the answer. I get that y1 is c1 e to the 5x. The second row tells you that y2 prime is 3y2. So again, by the proposition, we get that y2 is c2 e to the 3x. And finally, y3 is minus 6 y3. That means that y3 is a constant multiple of minus 6x. So because this matrix is diagonal, I have equations for y1, y2, and y3 completely separately. They don't mix, and so we can solve it with the baby case of what happens if you have an equation like this. And so we get that y1, y2, y3 is And notice that I'm using different constants because C1, C2, and C3 do not need to be equal. So where C1, C2, and C3 are arbitrary real number. Whatever you want, you can take. Alright, so now I'm after one specific solution that has this extra condition. So I'm going to start with the general solution here that says that my y is equal to this. I'll plug in x equals 0 and I'll see what it tells me about C1, C2, and C3. So y at 0 is going to be C1 e to the 0, C2 e to the 0, C3 e to the 0. And now we're asked to find a solution that has 2, minus 1, and 3 as their value at 0. So that means that C1 must be 2, C2 must be minus 1, and C3 must be 3. And so y would be 2 e to the 5x minus 1 e to the 3x and 3 e to the minus 6x. So for diagonal matrix, this is completely doable. It just comes back to the proposition. You just apply it 3 times. One for y1, one for y2, once for y3.